Hey guys, welcome to week 4. Woohoo! We're going to be talking about confidence intervals between two proportions. In last week's set of notes, we talked about how to find the null hypothesis, how to find the alternative, as well as do those conditions checks. This week, we're going to be doing the confidence intervals between two proportions. And in case you were wondering, in the middle of the video, if I yell at something to stop, I'm talking to my cats. Currently, Socks is trying to knock over my headphones, and Tiger is trying to eat a box. So, we're gonna see how this goes. So let's go ahead and start. The first thing that we're gonna do anytime we have one of these problems is the state. So let's see what needs to go in the state section. So for state, we're going to do our null hypothesis. The null hypothesis is always going to be that if you subtract the two proportions from the first set of data and the second set of data, there will be no difference. So this is like saying that the proportion of the first one is 2/5, and the second one is also 2/5. If you were to actually subtract it, it would be 0. There is no difference. Now, the alternative can be one of three things. So you can either have p sub 1 minus p sub 2 is less than 0, greater than 0, or not equal to 0. It can be one of those three things. Now, next step is we have to figure out what are the parameters in context. We're actually going to do that down here. Okay. All right, let me just do that. Okay, so the parameters in context are going to go down here. Now, what this means, can you not eat tape? Thanks. What this means is that you are going to say p sub 1 is equal to, and then talk about in words what in the world that represents. And p sub 2 equals whatever in the world you're talking about in your problem. In this section, you also want to figure out what is your sample size for your first set of data. You want to figure out what's your sample size for your second set of data. What is your sample proportion of the first set of data? What is your sample proportion for the second set of data? What is your confidence level? What is that percent? And what is Z star? A couple of nifty things to remember is that, here we go, Z star, this is from the bottom of table B. And also one really super important thing that everyone seems to forget. Proportions are always less than 1. Proportions. Yeah, that's probably spelled wrong. Oh, I wrote it right there. It's fine. Are always less than 1. If you don't believe me, look up the definition for a proportion. So your proportions are always going to be less than 1, always. If it is a number greater than 1, it is wrong. Now, means are the ones that can be greater than 1, but a proportion always needs to be less than 1. It is a proportion. It is part of a whole. So, let's look at the next one. The next one is going to be to plan. So our conditions for planning, we're going to be using the large counts condition because it is a proportion. So there are three things you have to check. The first one is it random? The second part is the sample size of the first set of data times the sample proportion of the first set of data greater than or equal to 10. also is the sample size times 1 minus p hat. There we go. Greater than or equal to 10. So we're trying to figure out if there 10%, is 10% of the data a success and is 10% of the data a failure. The third thing is you have to do the exact same thing, but with the second set of data. So you have to check both of those. They are now chasing each other around the apartment like psychos. So after you've checked all these 3 things and all 3 things are true, you get to move on to the next step. I guarantee you that the practice that I chose, you get to move on to the next step. And we'll go through that later. The next part is the do. You have to do the do. Like Mountain Dew. The soda. That's green. Okay. So in the do, we are going to do the formula. Okay. We're going to use the formula. It is very, very important that you use the formula exactly like I write it right here. So you have to do parentheses. P hat sub 1 minus P hat sub 2 plus and then minus, or minus and then plus, doesn't matter, Z star times the square root of P hat sub 1 times 1 minus P hat sub 1 divided by N sub 1 plus P hat sub 2 times 1 minus P hat sub 2 divided by N sub 2. Notice that all of this is underneath the square root, including these things on the bottom. A lot of times whenever we're typing in our standard deviations, because this is the equation for standard deviation right here, just the square root part, we forget that the sample size is included underneath the square root. Let's not forget that. And the final step is to conclude. So after you have done that formula twice, once with addition and once with subtraction, you are then going to conclude. You are going to use this sentence stem right here. So let's fill it in. So we are C% confident, so whatever your confidence level is, that the interval from the low number to the high number represents the true change in proportion of all population that, and then whatever the context is talking about. So whatever the problem is saying, context and problem, the interval suggests that, and then talk about the difference. So this part is essentially a fill in the blank. You just put in your answers and you're good to go. So these are all 4 steps for confidence intervals between 2 proportions. The next video is going to be the first example, and it'll be super fun. I will talk to y'all then.